Okay, I know everybody hates to hear about safety, but it's going to be the first part of this video, and darn it, let's get it over with. Alright, first, the variable speed zebra is for trained professional techs only. This safety section isn't intended to be a guide to HVAC safety in general. It's got some specific cautions that apply when you're using your variable speed zebra to diagnose or install HVAC equipment. Seek competent advice when you're unsure on how to perform a specific job or a function safely. To be safe, give the system and the wires a visual inspection first. If you see melted wiring, for instance, don't connect your variable speed zebra. You might expose it to line voltage and it will stop working. The variable speed zebra is designed only for HVAC blower motors whose control voltages don't exceed 28 volts. While we know of no other connectors that match those connectors on the HVAC blowers, don't exceed that voltage by trying to modify them. Carefully plug the connectors into their mating connectors. The pins on those 16-pin plugs are delicate. We didn't choose them, the motor manufacturer did, but we have to be able to match them. Those pins will break or bend if you force them. Gently wiggle those connectors together, and if they don't go together for some reason, don't push. Figure out why. For those of you guys that ignore this, we do offer replacement harnesses for the variable speed zebra. Don't use your variable speed zebra if it is wet, has gotten wet and hasn't been thoroughly dried out, or if the area that you're accessing the system at will experience rain while it's connected. The variable speed zebra's microprocessor cannot tolerate the trickle currents that water will introduce. Your warranty will also end. When you plug and unplug the connectors, the system power must be off. Don't introduce surges into your variable speed zebra. It might damage it. In early 2007, the variable speed motor in one form or another was installed in over 12 million units. The efficiency rules mandated by the U.S. government in early 2006 is drastically increasing the installed base of ECM motors. Many service techs are seeing these motors when they're responding to service calls for the furnaces that they're installed in. Many techs are seeing them for the first time. I remember the first time that I ever saw one, I says, where is the common high, medium, and low wires that I'm normally used to, and why are there 21 wires going to these things, and what do they do? The earliest units were made in 1992, so we're starting to see some breakdowns come through on those older units. When you examine a variable speed system for the first time, it looks complicated, and indeed it is. Besides the 5 lines that go to the power section of the motor, the 16 pins that connect up to the signal section of the motor have, besides hot and common, have many wires that run at half wave. They're rectified AC, so their voltages are hard to measure properly. And some of those wires, you can only tell what the signals are saying with an oscilloscope. A general voltmeter won't give you any good indication at all. The homeowner just tells you to fix it, please, and you might not be sure where to start. So we've made a tool that'll help you make an accurate diagnosis of the problem the first time. Remember, I might have mentioned earlier that 41% of the motors that are returned to the factory under warranty actually have no problem found. That says that the current generation of tools that's out there isn't as helpful as it could be in making a proper diagnosis of what's going on in these systems. The variable speed zebra is designed by technicians to be just that tool. GE makes an inexpensive tool, well, it's not terribly inexpensive, it's about 80 or 90 bucks, that just plugs into the motor. You hook it up and you turn on a switch, and they say if the motor runs on this one speed, the motor will probably run okay in all the other speed settings too, but they don't actually test any of those other speed settings. They don't give you any information about CFM and RPM. They don't allow you to monitor the signals coming from your furnace or air handler. And that's why the variable speed zebra was invented. Instead of just plugging into one of the motor connectors, as that other tool does, the variable speed zebra is inserted in line, in between the furnace, air handler's control board, and the motor's electronic package. It plugs into the existing 16-pin connectors, one male and one female, and is ready to begin its analysis immediately. Using the variable speed zebra dramatically reduces the likelihood of an incorrect diagnosis when a failure has occurred. But that's not all it does. Because the variable speed zebra reports system airflow in CFM, the tool is valuable when you're setting up a system for the first time. Balancing a system is much easier when you know the actual CFM a system is pumping at the blower. Many of these systems are dip switch adjustable up or down to meet a home's specific needs. The variable speed zebra reports those settings, those dip switch settings, with tricolor LEDs to enable you to make better choices when you're first installing a system. And finally, the variable speed zebra makes a great time comparative system analysis tool, enabling you to document the RPM, the energy required, to push a certain CFM through a system. If you document that system's values on initial installation, and you compare those values to new values that you might see when you do a spring or a fall checkup, you can spot trends that point to decreasing efficiency, or broken or open ductwork in attics or basements, or a system that might have too much of a restriction. Hi, I'm Bob. I'm one of the developers of the Variable Speed Zebra, and I wanted to show you how to use it to understand what's going on in an ECM system. One of the first things that you have to do is you open up your Variable Speed Zebra case and you get the cables out ready to hook up. The first thing that you're going to do is make sure that your furnace or your air handler, the power supply is off on it. So the next thing that you're going to do is you're going to disconnect the wires that are currently going to the motor on your ECM furnace or air handler. We just took a motor out of something else to demonstrate to you because it's really hard to see while you're back in there. The first thing you need to do is disconnect the power line motor by squeezing the two sides and pulling straight up on it. That allows you access to the tab, to this tab on the connector to the motor, which you have to squeeze in while you're pulling out. It's pretty hard to get to that tab while the 110 or the 240 power harness is hooked up to it. After you disconnected the power, open the door, whatever that shuts the power off to your air handler or furnace, you're ready to hook up the Variable Speed Zebra in line to that motor. So you take the 16-pin connecting wire that goes from the circuit board that used to plug into the motor, and you're going to plug it into the yellow harness on the Variable Speed Zebra. A few models of the Variable Speed Zebra have harnesses that are actually yellow here. Same thing. The other wire is blue there instead. But when you plug these connectors in, it's important that you take your time, because if you force these things, we didn't design these connectors, but we have to use them obviously to mate with them to get the signals. If you force them, you're going to wreck them, and you're going to end up having to buy a new harness for it, or you're going to have to buy a new harness for your furnace. Either way, it's a bad situation. Take 5 seconds, 10 seconds, and take your time hooking them together. The way you do it is you don't push them together like this. You gently wiggle them together like that until that little clip snaps until you hear it click. That way it's a good connection. We've already connected the blue harness to the motor because it's so hard to picture it. So we went ahead and did that before we started running the camera. And we've hooked up the power connector to the motor. After you've hooked up the two main harnesses of your Variable Speed Zebra to the furnace or the air handler and the motor, and turn your power back on. Oh, by the way, this small cable here, it's not necessary to hook it up at this time. It's only good for one thing, and that's testing this section of the motor. We'll review that later. But after you've turned it on, you look at your Variable Speed Zebra, your mode light should be flashing, alternating red and green. The camera has a little bit difficult time of showing that, but it does flash red and green alternating while it's waiting. You may find that one or more of the tap lights are lit. Those are indications of the switch settings, the little dip switch settings on your circuit board. Go ahead and pan over there, Lisa, and let's take a look at that switch. Let me just put that in there. You see that switch right there? Those set of dip switches, or sometimes they're little jumper settings where you place the jumpers on different pairs, but those things set up the taps. You're going to have to listen to the theory section of this DVD to understand what those taps do. I'm not going to try to go into what they do now, but different manufacturers even have different meanings for them. Whenever you're doing an installation for the very first time, or service where you have a motor that's running but there's a speed issue, or it's pushing the condensate off the coil because it's running too fast, or the customer claims it's running too slow, one of the first things you should do is check those settings. Let me give you a brief review on how these work. These are tricolor LEDs. If there's no light on, then neither one of the switches or shorting pins has anything on it. So in other words, both of those circuits are not doing anything. If the green light is on, the very first switch is in the on position, or the shorting pin is on the first set of pins. If the red light is on, then only the second switch in that pair is activated. And if this light is yellow, and you kind of got to look at it straight on to see the yellow light, it's not as clear cut as you'd like it to be, but if it's yellow, then that means both switches are activated. So that tells you, if you're familiar with that manufacturer and you see that, okay, the heat tap is red, you know at an instant that it's set up for a certain thing. If the adjust tap is yellow, you know that it's set to run at the highest speed that that particular air handle could possibly run at. So anyway, we're going back to what you do to start up. You've connected the variable speed zebra. Let's back out a little bit. You've connected the variable speed zebra in line, monitoring the signals from your board going to the motor. You don't see anything going on right now, but it's because this mode light is asking you to select a mode. We have two different modes that we can easily go into, and that's the observe mode and the control mode. I'll demonstrate the observe mode first. You just press and release the observe mode switch. This light that was flashing red and green now stays green to tell you're simply in the observation mode. So I went ahead and flipped a couple of the dip switches over here to give you different indications of, for instance, I turned the heat tap, the second switch in that series, on, so it's showing green, although it's a little difficult to see on the video that it is green. It actually is. So we've chosen our mode, the observe mode, and it shows green. I'm going to use, pan out for just a second, Lisa. We're going to use our ZebraStat to replace the thermostat, and we're going to turn the fan line on this furnace. Okay, let's go back and focus down here. After a few moments, that circuit board sends a signal down the fan lines to the motor, and you might be even seeing the circuit board shaking as it's rocking that motor back and forth, trying to determine which speed, which direction to start at. By the way, that's a characteristic of those motors, that they hunt back and forth a little bit when they first start up. There's nothing abnormal about that. It's not a cause to replace a motor. Let's focus down here on our display. Get really tight on that. Okay. As you look at the display, what we normally call a decimal point, you'll see moves back and forth about every 5 seconds. It's not a decimal point, folks. It's simply a light to tell you which display it's displaying. If that light is above the letters CFM, then it's displaying CFM, and you got to multiply it by 100. If that light moves over to this side, as it will right now, and it's above the letters RPM, it's displaying the RPM of the motor. And it'll change back and forth every 5 seconds or so to tell you what that motor's doing. It normally takes about 30 seconds after the motor reaches a speed before you can count on that being an accurate display. There is a bit of a time delay for the electronics that are coming out of the motor to be decoded by the microprocessor in your variable speed Zebra, and before it'll display that. So what this is telling us right now is this motor is running at 400 RPM. It's producing 600, remember you multiply by 100, it's not 0.6 and it's not 4.0, it's just 4 or 6 times 100. It's producing 600 CFM of air. One of the things that I love to show about how a variable speed motor works, let's back off just let's back up all the way for a minute, is how a variable speed motor works to maintain a CFM range. What these motors will do is, depending on the external static pressure of your system, is that they will actually change speed, increase or decrease the RPM to maintain as close as possible the CFM that they're being told to maintain under certain circumstances. For instance, we're on the fan only setting right now, and our variable speed zebra telling me that it's running 600, it's pumping 600 CFMs and running at 400 RPMs. What's neat, and I like to demonstrate, is if you put something to block some of that air on top of your furnace here, thereby increasing your static pressure, that motor will speed up dramatically. Remember, it takes a few seconds for this display to stabilize. That motor will speed up dramatically to try to maintain the same CFM. So it's speeded up, it's still pumping 600 CFM, and it's increased its speed now to 700 RPM instead of 400. Focus over here on this meter, if you will, please. That meter isn't the most accurate in the lower ranges, but it's telling us that that motor is drawing 1.1 amps. It's hard to see the decimal point, but it's in there. 1.1 amps, and stay focused right where you are. And I'm going to remove that restrictive cover that's putting external static pressure on our system. The motor slows down, and you can hear it slow down. Now can you see the display? It's drawing right at a half of an amp. So it more than doubled the amp draw when the restriction in the system goes up. Remember that as you're designing duct systems for it. Make these things as restriction free as possible if you want to keep your customer's total SEER in a low range. So besides our CFM and RPM display, which we're seeing on the variable speed zebra, you see there's two sets of green lights on here. We chose green for the fan since it's a common color to represent it. And you'll see that there's two sections of this. One is labeled from the board and the other one is to the blower. With the variable speed zebra, you monitor both sides. If you throw this switch, this mode switch, into control position, it will split this section. Right now in the observe section, when you're in the observe mode, any signal that lights up on this side will be passed along to this side. Okay, so if we turn, keep it right where it is, Lisa. If we turn the cool speed on, we notice our air handler speeds up a bit, and we notice the cool light comes on this side, and it's passed along, of course, to this side too. All we're doing is observing. So all these lights that are on one side will always be the same on the other side when we're in observation mode. Those lights are just exactly like you could see the electricity flowing in that wire. If that particular wire happens to be the signal line for the fan, you're seeing it's coming in from the board green and it's going out green to the motor connector. By the way, if there's a jumper on this particular power connector. It goes out the 4th and into the 5th pin. That tells you that it's a 120 volt configuration motor. If you have a jumper on there, that motor has to be running at 120 volt. Every ECM motor can be either 120 or 240 volts. If it has a jumper, you have to be running at 120 volts. If you have a jumper on it and you plug it into a 240 volt system, you'll burn this module out. Where you check your voltage on a motor is the first two pins that are away from this jumper side. The first one is the hot, the second one is the common if it's 110. If it's a 240 volt system, they're both hot. Gently put voltmeter leads, probes, touching the little contacts on those wires. If you see 240 volts or 120 volts across there as appropriate, and if this signal is sending out the signals to the motor on this side, you know you've got a problem somewhere in your motor. Basically what this is going to do is it's going to tell you where the problem is in your system. If you don't have any signals coming down to this side, and your thermostat has sent the signals to the board, then it's either telling you your problem is on the board or in the harness that comes from the board to the motor, which right now you have connected up to the variable speed Zebra. I've gone ahead and disconnected the power line going into that motor so it won't make so much noise as we're talking today. So you won't see a CFM and RPM display as we make some changes. But what I'd like to do is to explain to you that, for instance, we put the thermostat, or the ZebraStat, a moment ago into high-speed cool mode. When you do that, if your system is a two-speed system, then both of these lights are going to come on also, indicating that it's receiving a low-speed cool and a high-speed cool, and of course the fan signal from your board. It's also passing those along to the motor. If the motor's power connector was plugged in right now, you'd be seeing a CFM and RPM significantly higher than what we saw a few moments ago. Again, the variable speed Zebra's main purpose is to help you diagnose what's wrong with the system or to help you set it up originally. So what you're going to be doing is observing what's happening here with what's happening here, and then watching to see what the motor does in response. If it doesn't work, you're going to check the power coming into the motor like you did with these power connectors. If you haven't got any voltage coming in here, one thing that I might point out to you, let's zoom in on this side if you can see it. There's a little device that looks a lot like the system transformer. It's actually called a choke. It only has two wires going in. It's usually one of the hot wires coming to the motor from the power supply. And it's a filter to help filter out unwanted harmonics or radiation, or not radiation, but spurious voltages that your system might be generating. It's to keep it from affecting the motor and to keep the motor's spikes from affecting everything else in your house. Occasionally those things will burn out if the motor has put too much of a load on it or for whatever reason. So if you're not getting 110 or 240 and you are getting it on the board, check that item. Remember, we're in the observe mode. We're watching and observing signals coming from here, from your board, as they're passed along to the motor. Another way of diagnosing problems in a system, instead of changing your thermostat or using your ZebraStat to change the settings on your board, you can go into control mode, pressing the switch and releasing it in the control mode. Your mode light will turn red. It's hard to see from the video that it is red, but it actually is red. And your signals will stop going out to the blower. In other words, you can see the signals coming in from the blower, but they have absolutely no effect in control mode. And in control mode, you control what you want your motor to do. You'll use your setting step switch, up or down, and your option step switch to select what modes you want to send out to that motor, what signals you want to send out to that motor. Manufacturers use two different systems of sending those signals out. One of them always sends the fan line active anytime the motor is supposed to be active at all. Another one doesn't use that fan line active and only uses the fan line active when you're in the fan mode. The vast majority of them use the fan light on anytime any of these other settings are supposed to be turning the motor. So we're going to show you that way, but I'm going to show you that there's two different ways to access those settings. As you press the setting step switch up repeatedly, it's going to go through 10 cycles. And it'll go back to off when it's done. The first one is fan. The second one is small h1, that's low speed heat. Small h2, that's high speed heat. Small c1, that's low speed cool. Small c2 is high speed cool. Now you get into capital letters, capital H1, capital heat 2, capital C1, and high speed cool with a capital C. Let's go back to off for just a second here and we'll discuss those. If you run the small c or the small h, it will not turn the fan line on simultaneously. for those few systems that do use the command structure that way. Again, the vast majority of your motor manufacturer, your furnace manufacturers are going to use both those commands at the same time, so you'd use the capital letters. But to demonstrate, we're going to go to a small H1, which is low speed heat. 5 seconds after you quit pressing that switch, it will switch to that mode. So we see we only have the heat 1 mode light on right now. If we went, let's go up to a capital H1, 5 seconds later, it'll switch to that mode. The fan line will run simultaneously. Okay? So I'm explaining how to select which mode. We're going to run high-speed cooling with fan now because it's a capital C. Okay? We're going to run high-speed heating with a capital H with fan. And to demonstrate low-speed cooling without a fan, should be just one yellow light. Okay? Again, these lights have no effect on what the motor do when you're in control mode, red light mode. Red light means you're controlling it, green mode means you're simply watching it. So that is your setting step switch. These change the major thermostatic calls going to your motor: heat, cool, and fan. The option step switch changes two options that you have: the reversing valve and the humidistat satisfaction, or the humidistat line. Let's just call it humidistat. When you press those, HP stands for heat pump, i.e. the reversing valve. HU is the humidistat is active. BO is both, and OF is off. So we're going to turn this on so that the heat pump, it's in other words, it's not sending a line, it's not sending a signal to the heat pump, the reversing valve right now. If your system was actually hooked up and you had a reversing valve on there, it probably would be receiving that signal. This light doesn't mean it's sending a signal to it. What it means is that it's telling the motor that the reversing valve has been activated. In many systems, what that means, if you are running a heat pump, that the motor should slow down a little bit because it's in the heating mode as compared to the cooling mode. So in a heat pump system, these two lines, the heat 1 and the heat 2, you'll probably never see them come on. What you'll see is the two cooling stages and or the reversing valve line, indicating that the heat pump is being activated in that mode. The humidity line or humidistat line is when you have a call to reduce the airflow over the coil to increase your temperature difference so that you can remove more moisture from the air. When that line is active, typically your motor will slow down a few percent so that that TD increases, and the rate of condensation removal, of course, will increase then too. So we've talked about which mode you're in, observe or control. Observe passes along those signals. Control splits those signals so that whatever is coming from the board stays there, but it doesn't get to the motor. You use the setting step switch and the option step switch to select which lines you want to activate going to your motor. In this case, we've activated high-speed cooling, low-speed cooling, which is high-speed cooling together. The reversing valve is activated, so it's in heat pump mode, and the humidistat is satisfied, which of course in reality this would never happen. You wouldn't be running in heating and using a humidistat to remove humidity from your air. And the fan line is active, so it's on a system that uses the fan line, and of course the vast majority of them do. Normally you'd be receiving feedback from your motor right now about the CFM and the RPM that the motor's running at, but we shut it off because of the noise that the fan generates when it's in those higher speeds. A couple of other things you need to know about the variable speed zebra is there are two other features available to you here to use in diagnosing your system. The voltage line, a lot of people don't stop to think that a transformer could have a problem and be producing low voltage or high voltage or something that would interfere with the system, we give you the ability to monitor that voltage by pressing and holding the side of the switch that says voltage. This particular system at the motor is receiving 26 volts of power, which is just fine. Anything under 30 should be sufficient for that motor to be very happy, and as long as it's over 21 volts, that motor should be receiving enough voltage on the low voltage control circuit to process the signals properly. So there are 7 signals that your system can change going into that motor to give it commands about what speed to run at. The 2 heats, the 2 colds, the reversing valve, the humidistat, and the fan. There are also 4 signal lines that control the taps that cannot be varied every day, i.e. you're setting those with a dip switch or with a jumper. Those 11 lines give your motor quite a bit of versatility in providing your customer with good conditioning. So let's say that you've verified that there's power going into your motor. You've tried the observe mode and you've watched those signals going into the motor, but the motor doesn't work. And you've gone to the control mode and use your setting step switches and your option step switches to try a bunch of different motor speeds, and the motor just doesn't go, period. So because it's getting power and because it's getting signals, you know that that problem is somewhere in your motor. Let's pull out a little bit. So at this point, we're thinking that we've got a problem inside of our motor. It's getting high voltage power. We've verified that by putting a voltmeter at these terminals on the high power harness, and we've verified that it's getting a signal going in on the signal harness. Many manufacturers allow you to replace just this section of the motor if it's bad. So the next step you want to do is to determine which section of your motor, the winding section or the electronic module section, actually has the problem. The first thing to do is to shut off the power to your furnace completely, probably best at the circuit breakers. Then remove the motor. There are 2 bolts that I've already removed that hold this module to the winding section of the motor. Don't remove either one of those 2 bolts until you've waited 5 full minutes after you've removed the power connector from the motor. This motor has large capacitors. See the warning high voltage thing says allow 5 minutes after disconnecting before opening motor. That's a real serious thing. The charge that's in there can knock you across the room. And it's quite embarrassing when your customer has to wake you up and say, "Are you okay?" So wait your 5 minutes. You're being paid for it. Wait your 5 minutes before you take those 2 bolts out of the motor. Once your 5 minutes has passed, and it has for us, take the 2 bolts out. Inside the motor, there's only a 3-wire harness going between the winding section and the electronics module. There's a little connector on the end of that harness, and it has a squeeze tab, which is a little difficult to get to, but you must push the squeeze tab in before the connector will release. Can you see the squeeze tab there? Okay. That squeeze tab is what connects up to this 3-pin harness that we spoke of earlier. It'll only go in there one way. And it goes in a lot better than those 16-pin connectors do. A lot easier, I'm sorry. The alligator clip that's on this harness needs to be attached to the motor. To do this test properly, you really need to have the motor out of the furnace. I know that's a lot of work, but you're going to have to take the motors out anyway, because you're either going to replace this section or you're going to replace the whole motor. You can't see this section. You're either going to replace the electronics section or you're going to replace the whole motor. There's no easy way to test the electronics section directly, so if you know the fault is in one of these 2 pieces, you can determine if there's a fault in here, and if the fault is not in here, therefore it has to be in here. So that's what you're going to use our variable speed zebra for now. This is called the winding test. You accomplish that test by you have to have power coming into the variable speed zebra from your furnace board to do that. Your other wire does not have to be connected. The blue harness on your variable speed zebra does not have to be connected to do this test. But you accomplish the winding test by simply pressing and releasing the winding test button. On your display, you'll see a little Pac-Man type thing chasing itself around there in a circle. That's to remind you that you need to rotate the motor 1 or 2 revolutions. It does not matter how fast to initiate this test. This is a motor with permanent magnets in it that actually generates voltage when you turn it. It's just like a DC motor. So when you spin that shaft, you're generating a voltage in there that we use to do a number of tests. It performs about 15 or 20 different tests that, for the most part, you could perform with a voltmeter, ohm meter, but it makes it a lot simpler. So you press the winding test, you see the little thing chasing it, you spin the shaft once or twice. 3 or 4 seconds after that, it's done its test. In this case, it displays a 7-7. On the inside lid of your variable speed zebra, there's a dozen codes listed down there that tells you what those codes mean. A 7-7 means all clear, all tests okay. So the winding section of this motor has no problems in it found. Don't replace this unless your motor manufacturer will only allow you to replace the whole motor as one unit. There's a couple of manufacturers we've heard that are doing that, probably because people were making so many bad choices about sending in the wrong parts. This way you can make an accurate test as what's wrong. You know that the only problem now has to be in this electronics module. They typically cost you, the dealer, less than $100. So hopefully you don't have to spend $400 or $500 for your customer, your cost, to buy a whole new motor assembly. One thing you should know about motors in general, if you have a failure in the winding section of this motor, you need to replace both pieces, because any failure in here generally will cause a failure in here. Okay? If you have a failure in the electronics module, unless your manufacturer requires it, you don't have to replace the winding section. It's far more expensive to replace the winding section. So again, let's go through that winding test. Let me demonstrate how this test might show. For instance, if you can plug this plug-in incorrectly if you only plug in 2 wires of it. So I'm just going to demonstrate what happens if we leave one wire not connected like this. We'll ask it to do a winding test. It won't even ask us to spin it because it's already determined with a code 22, which says that phase B on that motor is open. It's already determined that there's something wrong with it. It stops at the very first failure on that motor. So it says, hey, there's a winding open, buddy. You don't even need to spin that thing. I can tell you you're going to need to replace it. There's 2 additional lights on the variable speed zebra that we ought to touch on. One's called your low volt light and the other one's called a short light. The low voltage light is hooked up to this voltage circuit. Remember when you could press this switch and get a display as to how much power on the low voltage side is actually coming into the motor circuits? This said 26. If it said less than 20.5 volts, this low volt lights will be flashing continuously to let you know, don't even bother doing any of these other tests. It's just a little reminder that says, don't bother, here's your problem right here, buddy. The short light would only come on if something inside this electronics package was shorted and you powered up the system and the variable speed zebra, instead of seeing the right signals in here, saw a direct short. That light will come on indicating that a circuit breaker has tripped in the variable speed zebra. It's an automatic resetting circuit breaker so that when you disconnect the power and disconnect the problem and turn it back on, the circuit breaker will reset itself. But it's saying, hey, shut this thing off right away. You got a short in the system. Don't leave it on any longer than necessary. Automatically, at that point, you know you've got a failure in your electronics module. This is the circuit board that's inside the variable speed zebra. There's a small microprocessor along with a number of other integrated circuit chips that process the signal circuitry that goes into and out of the variable speed zebra. As you can probably guess by seeing computer parts in there, you understand what happens if it gets wet. Don't let the inside of your variable speed zebra ever see moisture. If you do, you got to make sure it's completely dry before you let it run again. We don't recommend you ever take it apart, but if you do have to take your variable speed zebra apart, these 4 screws are not the proper way to take it apart. You won't get it apart that way. There are 2 screw holes in the side of your variable speed zebra, one on this side, one on the opposite side, and recessed in there is a small Phillips head screw. And it's those screws that you use to disassemble the variable speed zebra. You take those 2 screws out and this whole assembly will come straight out this way. You cannot get to the front of this plate when you take it apart. The only thing you're going to be able to see is the back. Okay, so what you're going to have to do is probably take some compressed air and dry this out. Don't don't plug in or power up your variable speed zebra. If there's any hint of moisture in there, your warranty will be voided if it blows out the computer parts. They're pretty delicate. The 2 connectors that are on the back of the board are for replacing your wire harnesses should you ever need to do that. You take out those 2 screws in the side of the case, and the strain reliefs right here can be released with a pair of pliers. You have to take those out, and then you can replace the cable. They simply plug in gently to here. The yellow colored cable plugs into this top connector, or this connector right here. The blue colored connector plugs into this bottom one. Hopefully you never have to replace both of them at the same time. But if you do damage them by being a little too rough when you're plugging them in, this is the procedure for doing that. If you ever handle this board, remember that static electricity can be an issue. So don't handle it while you're in a low humidity situation, i.e. in the wintertime while you're standing on carpet and your sister just shocked you by touching you while she walked across the carpet. That would be a bad time to ever open one of these things up. If you watch the theory section of this video, you saw that there are a number of releases of variable speed motors, starting with one back in the late 80s, early 90s, that this tool probably does not connect to. We haven't actually seen one of those motors, so we don't know, but we know that they started getting popular with version 2.0. This tester will work with version 2.0 and version 2.3 also. Those constitute over 95% of the installed motors out there in 2007. Now, as time goes on, the newer motors, which one of them is a version 2.5, which is mostly used by Carrier, which uses a special communicating thermostat, which has software and sort of like a serial stream on your computer, like it goes to your modem. It uses a communications protocol from the thermostat to the motor that communicate back and forth. The variable speed zebra, nor any other tools that we know of at this time, can work with that motor. Most of those motors are in version 2.5. There's also a new protocol that just came out in early 2007 called the version 3.0 ECM motor, and currently there are no tools able to communicate with that motor. As time goes by, we're striving to update our equipment and our reprogramming. One of the things that we can do when it's available is, for no charge, we will reprogram. All you have to do is pay the shipping, your VZ-7, to update that firmware to work with newer and newer systems. I don't know if we're going to be able to do that to work with every new system. At this point, Carrier doesn't appear willing to release their communications protocol for the version 2.5 motor that they run in a lot of their systems, and if they don't, we're not going to be able to use our tools to work with it. Your variable speed zebra will work with versions 2.0, 2.3, and if you purchase the X13 motor adapters, it will work with the X13 motor, which is starting to become a very popular motor. So it will work with about 95% of the installed motor base. On the back of your variable speed Zebra manual is our warranty statement that essentially warrants your VZ-7 to work for 1 year if it's not abused. Although the variable speed Zebra is designed to be used in a service environment, experience has shown our service department 2 areas where tool failure has often occurred. The first one is when somebody modified an input connector and they've introduced voltages higher than the VZ-7 was designed to withstand, i.e. higher than 24 volts. The second area, the biggest area where problems have occurred, is when appropriate care was not taken when plugging in connectors. Therefore, if you want years of trouble-free service, we've got 2 suggestions for you. Number 1 is don't modify the connectors on the VZ-7. And number 2 is when plugging connectors together, use very little pressure. Gently wiggle those mating connectors together or pull them apart. Again, since those motors were designed with that particular set of connectors and pins, Zebra Instruments doesn't have any choice in using them. If you encounter problems assembling a connection, examine those connectors first. Never force them, not even once, or they'll probably be damaged. Your warranty will not cover bent, crushed, or broken connector pins. We do, however, have those replacement wire harnesses available. Please visit our website, www.zebrainstruments.com, and look under the service and warranty for details. Here at Zebra Instruments, we try to make innovative products that assist you in diagnosing and helping your customers with their products. The variable speed Zebra is one of those products. It helps you avoid, well here, let me give you a figure. 41% of these motors that go back to the factory as warranty motors get charged back with no problem found. That's a substantial amount of motors. The variable speed Zebra came out of that fact so that we can help you not make a mistake when you make a diagnosis on an ECM system. The next biggest cause of failure for an ECM motor is surges and spikes wrecking the electronics in the end housing. To that end, we've come up with a product called the ECM Protector. It's a plug-in device that plugs into the motor before your normal power cord plugs in. Sits there in line with it. It's terribly easy to install. If you want a little bit of added protection, you hook up this second ground strap to a good metal connection inside your furnace. It's a fast add-on sale to help your customer protect their equipment. ECM Protector. There are 4 harnesses available for the variable speed Zebra. 2 of them, sadly, are the harnesses that come with your unit. The one that sometimes has a blue braid here has now been replaced with a blue connector on the end. The connectors are the same, it's just it's a more professional wire. Every once in a while we know somebody's going to jam those things together and it's going to mess up your pins in there. If it happens, at least replacement harnesses are available for you. Go to our website to see how you can order those or check with your distributor. The other 2 adapters that are currently made, one of them is for the X13 motor. It's an adapter set with a DVD and instructions. The X13 motors are true variable speed motors, but they have a different connection pattern on them. They have quick connects, all of them in a little white block, instead of a 16-pin low voltage and a 5-pin high voltage like these type of ECM motors have. They use a row of quick connects. And those are called the X13s. They're starting to become very popular after January 2006 guidelines came out for higher SEER in furnaces and air handlers. This This is an inexpensive way to be able to properly diagnose and monitor the signals going into and generate your own signals going into the X13 motors. The other adapters that we have available are the Coleman-York adapters. What we found is Coleman doesn't always run a 24-volt hot power supply line to the ECM motor. The variable speed Zebra needs that to be able to work. This gives you a safe access so that you can hook on a 24-volt hot line and run your variable speed Zebra. Our newest product at Zebra Instruments at mid-2007 is called the Short Pro tool. It was invented by a technician in San Antonio. We saw his efforts at making the tool and we really liked it. This is an inexpensive tool that makes it fast to find shorts in air conditioning systems without blowing a pocket full of fuses. I mean, how many times have you been tempted to put a jumper wire over a fuse on Mrs. Cartwright's board so that you didn't blow fuse after fuse while you were looking for wherever it was that line was shorted? You know, maybe the dogs chewed through it on the outside, or maybe the contactors or gas valve shorted. This is a way to do that safely. It's got an automatic resetting circuit breaker with a strong LED red light that tells you when the circuit breaker is active. When you remove the short or remove one of the alligator clips, it automatically resets. It's pretty cool. Ask for it. How many times have you had to go to an automotive dealer to find fuses for the air handlers and furnaces that you work on? I know this is a little thing, but we make them. This is an assortment, but we also make 25 packs of 3 amps and 5 amp fuses. One of our developers here at Zebra Instruments, who was a tech for 25 years in the industry, said one of the things that made him the maddest is when he used alligator clips in his service work and it was a hot day or he put a decent load on them, the darn alligator clips fell off the wire because they were just crimped. Zebra's answer to that was to compete with those offshore, those made in China or Taiwan alligator clips, and have quality wire sets made in the USA that are soldered together. They will not fall off, guys. And they're not any more expensive than those things that are made offshore. I know none of you techs have ever done this, but you probably all heard of somebody who's done it. It's hot. It's a Texas summer afternoon. It's the last call of the day. You're out there ready to put your vacuum pump on a system and pull a vacuum, and you're tired, you forget about it, you're sweaty. You hook up the alligator clips on your little cheater cord so you have power for your vacuum pump. You hook them up to the contactor and you accidentally forget, oh darn, 240 volts. You've blown your vacuum pump. You hear the vacuum pump make a horrible noise when you start it and you know what happened. We've come up with something that helps for people who do that. It's our Zebra adapter. Not only does it have a safety fuse in case you do hook it up to too high of a voltage, it'll probably blow the fuse, but one of the other features that's in it, it's a little hard to see. One of the other features that's in it is the end of the cord lights up with a nice, gentle, warm light when you hook it up to 110 volts. If you hook it up to 240, it's very bright. Plus the safety feature of the fuse is likely to save you a vacuum pump someday. And again, it's a product that's really not any more expensive than the offshore things that you find that don't have these safety features built into them. We also have a male version that plugs into the wall. You'll see us using that to demonstrate the VZ-7 on the rest of this video. It's for testing motors or whatnot. It's got a safety fuse built into it and of course a light that tells you when it has the proper power. Zebra Instruments' very first product, called the Zebra Stat, came out with it in 2005, 2 years ago. A nifty little tool to assist guys in working with air handlers, heat pumps. It really shines when you get into multi-stage things, rooftop units. It does 5 functions. One, we used it on our demonstration tape here. Is simply a remote control. Instead of having a thermostat somewhere on the wall and having to switch it back and forth, we used the Zebra Stat to actuate the various modes in this furnace. Why don't you zoom in here a little. The Zebra Stat has an activate side, which is what we talked about a minute ago, the remote control feature. It also has a continuity checker. When you put this switch in this position, it does 6 simultaneous continuity checks to make sure that you at least have an electrical path going to those devices that are downstream of your thermostat wires. The middle position is simply a monitoring position if you're using a thermostat or other device to control it. And with the yellow lights down here, you can see what's active and what's not. The fourth feature that the ZebraStat does is it automatically monitors voltages with these lights. If all 3 red lights are on, you've got great voltage coming from your transformer. But if you ever notice that 1 or 2 of these lights are out, it says that you've got questionable or not enough voltage to pull in a contactor, for instance, on your outdoor unit. The fifth feature is that you can use the ZebraStat as an automatic resetting circuit breaker. And that's what this light and this light comes into effect. It acts as a 3 amp or a 5 amp circuit breaker, so you can test circuits without fear that you're going to wreck a circuit board. You might have to take a fuse out looking for a short, for instance. And when you use this according to the directions, it will keep you from damaging those boards.